Welcome students. We've got an exciting concept to tackle today. Let's dive straight in. In our last lesson, we solved problems involving the sum of an arithmetic series. Today, we will explore geometric progressions, another type of sequence. Grab your notebook and let's get started. Note down the following. A geometric progression, or GP, is a sequence where each term is multiplied or divided by the same number, called the common ratio, denoted as R. To get the common ratio of a sequence, we divide any term by the previous term. For example, in this sequence, 6 divided by 3 is equal to 2. 12 divided by 6 is equal to 2. And so on. So, the common ratio is 2. Now, let's look at another sequence. To find the common ratio, we divide each term by its previous term. 45 divided by 135. Let's solve. 45 divided by 45 is 1. 135 divided by 45 is 3. The result is 1 over 3. 15 divided by 45. Let's solve. 15 divided by 15 is 1. 45 divided by 15 is 3. The result is 1 over 3. And so on. Therefore the common ratio is 1 over 3. Now that we have explored how to identify a geometric progression and find its common ratio, let's move on to finding the nth term of a GP. We can find any term in a geometric progression using this formula. U sub n equals a times r raised to power n minus 1, where u sub n is the nth term, a is the first term, r is the common ratio, n is the term position. Just like in arithmetic progression discussed in lesson 14. The nth term formula allows us to find any term without listing all the previous terms. Let us now look at some examples applying this formula. Example 1. Given the geometric progression, find its ninth term. Solution. In the GP, the first term, a, equals 5. To get the common ratio, we divide any term by its preceding term. 10 divided by 5 is 2. 20 divided by 10 is also 2. And so on. Therefore, r equals 2. The term position, n equals 9. Now let's substitute the values into the nth term formula. U sub 9 equals 5 times 2 raised to power 9 minus 1. Let's simplify the power first. 9 minus 1 is 8. So we have 5 times 2 raised to power 8. Solve 2 raised to power 8 with your calculator. The result is 256. 256 times 5 is 1280. Therefore, the ninth term of the GP is 1280. Let us look at another example to boost our understanding of this concept. Example 2. If the first term, second term, and last term of a geometric progression are 3, 9, and 243 respectively, find the number of terms in the GP. Solution. From the question. The first term, a, equals 3. The second term, u sub 2, equals 9. The last term, u sub n equals 243. We need to determine the number of terms, n. To do this, we'll first find the common ratio, r. To find the common ratio, we divide the second term by the first term. 9 divided by 3 is 3. So the common ratio is 3. To solve for n, we'll use the formula for the nth term of a GP. Let's substitute the values into the formula. The last term is 243. Equals. The first term is 3. times. The common ratio is also 3 raised to power n minus 1. To isolate the exponent term, we divide both sides by 3. 243 divided by 3 is 81. Equals 3 cancels 3 to become 1. So we have 81 equals 3 raised to power n minus 1. Now, we need to express 81 as a power of 3, since our equation has 3 raised to power n minus 1 on the right hand side. To do this, we keep dividing 81 by 3 until we get 1. 81 divided by 3 is equal to 27. 27 divided by 3 is equal to 9. 9 divided by 3 is equal to 3. 3 divided by 3 is equal to 1. Since we divided by 3 4 times, we can say 81 is equal to 3 raised to power 4. So, our equation becomes 3 raised to power 4 equals 3 raised to power n minus 1. Since the bases are the same, we'll equate the exponents. To isolate n, we collect like terms. So we have 4. When minus 1 moves to the left-hand side, it transposes to a positive number. Equals n. 4 plus 1 is 5. Therefore n equals 5. So, the GP has 5 terms. Assignment. Write down the following assignment and attempt it yourself. Solve the following. Take your time to work through these questions carefully. In conclusion, we explored geometric progressions. How to identify them, how to find the common ratio, and how to determine the end term. In our next lesson, we'll take it a step further by exploring the sum of a geometric series. Keep practicing and stay focused. The more you work with these concepts, the easier they become. Thanks for joining me today. Goodbye for now.